neuropsychiatric diagnoses, the medical diagnoses in the individuals with P10 and autism versus P10 without autism. And in general, kind of across the board, there isn't any statistically significant difference in one group compared to the other, but definitely, once again, this is preliminary analysis, and we need to look at each of these different things in a lot more closer detail. So yeah, this is just a continuation of some of the medical issues in each of the two groups. So lastly, just wanted to end on future directions. So there's a lot of potential future directions. So continuing to look at the baseline data. There's a huge wealth of data in terms of language measures and other behavioral measures and cognitive measures. And I think there's a lot of information we can glean from this data and provide insight to families about expectations for the future and management of symptoms. I haven't even touched base on the longitudinal analysis of data, meaning looking at the instruments, the data that's been collected over multiple time points to see what sort of salient trends become apparent over time. And then the MRI data in terms of, I'm a neurologist, so I'm very interested in much in the brain and neuroimaging, so that I think there's a lot of really interesting information from that is to be determined. So lastly, just to kind of end on acknowledgments, thank you guys. Thank you to all the families who have come out here. Thank you to my team at Boston Children's Hospital, including my mentor and the research coordinators, Mia, Dr. Sahin, and Kira and Raina, who are part of the BCH team. Any questions? Yeah, go ahead.
May I ask a question about the white matter with the brain, so not linked to the Everolimus study?
Right.
Is there any, and I'm not a medical professional at all, so I know that my son on his MRI, that he had white matter. I've talked to other parents that seemed like their children had white matter as well. Wondering if there is any research or any thought into, there's like a place called the Brain Treatment Center, and they help a lot of people who have had traumatic brain injuries, working with the brain to try to get things firing and all that kind of stuff. Is anything like that has that been looked at?
You mean, and I'm not too familiar with kind of the treatments that they do. Can you kind of explain what they do, what they offer?
We're looking into it now as well, but I think it's stimulating certain parts of the brain, and so I didn't know if any of that has anything to do with the white matter.
I see. Well, I think I understand. One of the tricky things about MRI is that it can be a marker of dysfunction, of things that are not working as effectively, but it doesn't necessarily mean it might be the cause. So for example, just in general, not just P10, but in general in neurology, so you can have some children who are extremely affected, who have normal MRIs, and other children who are mildly affected with very abnormal MRIs. So sometimes we just have to be careful about making conclusions of whether it's the changes you see on the MRI, are they reflective of a marker of the kind of overarching cause, the P10 mutation, or are they actually the cause of the dysfunction? But if you can do an intervention that changes the MRI, I think it's also important to make sure that not only do you have a change in MRI, but you have a change in functional status, like an improvement in symptoms and neurological and cognitive symptoms. I think that'll be important for any kind of intervention study.
Right, so in fact, in a study by Dr. Fraser and our team, we have indeed shown that people with P10 mutations and ASD not only have a big head, it's big white matter, exactly as you say. People with P10 mutations without ASD with a big head don't have that super expanded white matter, they actually have more gray matter. Now, it doesn't mean that they don't have more white matter than the general population, probably do. we are looking into that. It's quite puzzling. So we looked at the message. So I said the gene's the master, then it's the protein. I did not tell you that there's a messenger between the gene and the protein. We looked at the messengers from all of the 30,000 genes, the 30,000 encyclopedias, in mouse models, not humans. And indeed, it looked as though that the white matter proteins are up and cholesterol is up because, as you know, white matter, there's a lot of cholesterol. So we chased that cholesterol route and then we got nowhere. So we're actually looking at things outside the brain that might cause this. Now, I mean, he's absolutely right, Dr. Sid's right, that is it cause or is it effect? So it's very complex. So before we actually stimulate things, I think just echoing that we need to make our observations with scientific rigor. Thank you.
Thank you, Dr. Sid. Very informational. Okay, at this time, we're going to take a small break. There's some waters in the back. The restrooms, again, are just right outside this room. Travel stipend in the lobby. There's bagels back there. We will have lunch coming at 11:30, and then be back in here at 10:30 to hear from Claudia.